All right, so here we have kind of a long one. So it says the natural gas line running along a river is to be connected from point A to a cabin in the other bank located at point D as illustrated in a figure. The width of the river is feet and the distance from point A to point C is in feet. The cost of running the pipe along the shoreline is dollars per foot, and the cost of running underwater is dollars per foot. Now the cost of connecting the gas lines from A to D is to be minimized. Complete parts A through E. Okay, so now we have all these. So it says write an expression that gives the cost of running from A to B if the distance between these points x is fixed. All right, so that's going to be a key here. And one thing they forgot to mention was, or what they forgot to put is, and this whole thing, they forgot to say that the cost of running along the shoreline is, and they didn't give us a dollar. So this is actually $30 per foot, and this one here is actually 50. So I had to look that up because they forgot to give us what those values were. And so with that said, A is going to be what? Well, if we're just running from over here at the from A to B, that's along the shoreline, that distance is X. We're just going to take the cost per foot, which is we found as up here 30, is just going to be 30 times X. Okay. Now we're supposed to find the distance from B to D. All right. So the distance from B to D. How are we going to do that? Well, we need to use the distance formula. And so I'm going to go ahead and come down here and we're going to take, and it's the square root of, and we know the distance from across the river. That distance we know is 488 feet. Okay. So that part we have that down. So that's good. So what we're going to say is that's going to be 488 squared. Again, we're just using the distance formula. And now we need to know how far it is from B to C. Well, how far is the whole distance from A to C? Well, that's 1,000, but we already took off X, and so now we just need to have here. So that's going to be 1,000 minus X squared. So that's going to be the distance from basically our B to C, and then we have our distance from D to C, it's going to be the 488 squared. So the distance overall from B to D is going to be this, and they say just write the expression, don't evaluate it. So that's going to be B. Now C, what does it say? Write the expression that gives the cost of running a line from B to D. Well, that's underwater because it's under the river, and now we know that, hey, it's $50 per foot, so it's just going to be 50 square root of 488 squared plus 1,000 minus x squared. So that's our C. Okay. Now, what we're supposed to do is write the total cost going from A to B to D. So basically, we're going to write and say we're going to take this value plus this value, and that's going to be our cost. So that's D. Okay. So we're going to take 30x plus 50 times the square root of the 488 squared plus 1,000 minus x, the quantity squared. So that is going to be our cost, okay, for A to B to D. Okay. And then it says graph the expression. So now what I'm going to suggest is let's go over here and use our calculator to kind of get a good idea of what the graph looks like. So what we have is we have to type in that whole equation. So we have what? We had 30x plus oh yeah, it was 50 times the square root of, now we had what, 488 squared, and then we had plus, and then we had 1,000 minus x, and that was squared. Now we have to kind of figure out a window. Now for the window, I'm going to suggest let's go from 0 to 1,000. I don't know what it is, but I looked at the graphs they have below there, and they actually have kind of a thing before you copy it and paste it in here. It had a idea, and that was going to be, so let's go from 40,000 to 60,000. And I don't know, let's do by 5,000. We could do by 10,000, but it doesn't matter. And so now, fingers crossed, let's make sure we don't have any stat plot turned on. That's what it's going to look like. Okay. So that's what our graph looks like. And so if we go back over here, I'm thinking what that one is it's probably going to be this one here. That looks to be the most similar. And I wonder if I can kind of screen capture that and take it back over on the other side. So let's see if we can, and we'll get the same idea. So that, and now let's go back to here. And so I don't think you can see what I'm seeing, but as far as if we go back to sharing our screen, PowerPoint, it's going to be, yeah, it looks like it's going to be this one here. So that would be our example in this case. So let's pause with a second here. And what we're going to do is we're going to mark this one as the one it's the closest to because it came down like this and went back up here. So based on the screen we had before, again, let's go back over here. And so this is kind of what it was. And so it went up and it was pretty close to this line, which means that was the closest one to B because the other one, it actually was coming up, or my marking tool go, it was actually a little higher. It was all the way up here. And so that wasn't C, and the others were much lower. So that was the only one that it actually could be is actually B, okay? Because this one's much higher, this one's much lower, and this one's much lower. So it has to be the second one here. All right, so that's all I have for this section, so hopefully that helps.